In this second outcome, we turn a good question into a workable plan, mapping out the stages, the proposal itself, and the method you'll use to gather evidence. Here's a hard truth. Even a brilliant question falls flat without a realistic plan behind it. Planning breaks the project into stages, sets deadlines, and matches the work to the time you genuinely have. It also settles how you'll gather and analyze your evidence, which is your methodology. Across this outcome, we'll look at the stages of a project, the outline proposal you write up front, and how to choose and justify a method. Say, deciding a survey rather than an experiment fits a question about attitudes. Let's walk through the key stages of a research project. You agree the title and question, read the background, and refine your plan, then design the method and prepare your tools, whether that's a survey, a benchmark, or an experiment. After that, you collect the data and analyze it, and finally you write up your findings, reference your sources, and review everything before submission. One thing worth remembering is that these stages overlap, so your background reading carries on even while you're collecting and analyzing data. It can help to picture the process as 5 clear phases. First, you define agreeing the title, question, and objectives. Then you review, reading the background and similar studies. Next, you design, choosing your method and building the tools before you collect, running the benchmarks, surveys, or experiments. Finally, you analyze and report, interpreting the results and writing them up. So, for an app usage study, defining might be pinning down which apps you'll track, and collecting is the fortnight you actually log the data. A Gantt chart is your friend for scheduling. It shows each task as a bar stretching across the weeks of your project, which makes overlaps, deadlines, and the critical path easy to see at a glance. It also flags when data collection has to begin if you want to finish on time. Tutors will expect a timeline like this in your proposal so they can track your progress. And honestly, even a simple 12-week schedule sketched out will save you from nasty surprises later. Alongside the schedule, think about milestones, deadlines, and contingency. A milestone is just a checkpoint, something like proposal agreed or data collection complete. Work backwards from your submission date to set those milestone dates realistically, and always build in contingency because equipment fails and survey responses trickle in slowly. For example, leave a spare week before write-up in case a benchmark has to be run again. Then review your progress against the plan each week and adjust early if you start to slip. Let's talk about what actually goes into a research proposal. It's a short, structured document, usually somewhere between 1 and 3 pages. It states your title, the background, your aim and question, the method, the resources, ethics, a timeline, and some initial references. Remember, it's a plan, not the finished report, but it needs to be complete enough that someone could act on it. A good proposal lets a reader see exactly what you intend to do and judge whether it'll actually work. Every section of the proposal has a clear job, and each one follows on from the last. The background and rationale justify your aim, while the method and resources show the work is actually feasible. The timeline and references, meanwhile, demonstrate that you've planned and prepared properly. Think of it as 7 pieces that together tell a convincing story, so that by the end a reader trusts you've thought the whole thing through. Let's name those sections and what each is for. The working title names the study precisely. The background and rationale show what's known and why the project matters. The aim, objectives, and question state exactly what you'll answer, and the methodology explains how you'll gather and analyze evidence. Then resources, ethics, and risks confirm the work is feasible and safe. The timeline gives your Gantt chart of tasks and milestones, and the initial references list your early sources in Harvard style. Here's what a completed outline proposal looks like for that solid-state drive project written before any testing begins. The title asks whether swapping the hard drive for a solid-state drive improves everyday performance on a 2015 laptop. The background notes that solid-state drives use flash memory and report faster access, but that the effect on older machines is less documented. The method is a controlled experiment, timing the boot, 3 application launches, and a 4 GB file copy with 5 repeats each on the same laptop. It lists the resources, notes no personal data is collected, and lays out a 12-week timeline. Don't overlook ethics, risk, and resources, because even small computing projects raise them. If people are involved, a survey needs informed consent, anonymity, and safe data storage under GDPR and the BCS Code of Conduct. List the resources you'll need, the hardware, software, data, licenses, and access, and honestly assess the risks, whether that's losing data, equipment failing, or simply not getting enough survey responses. Crucially, where ethical approval is required, it must be agreed before you collect a single piece of data. Let's get our terms straight before going further. Your methodology is the overall approach and the reasoning behind how you research your question, whereas a method is the specific technique you use to gather data, like a survey, an experiment, or a benchmark. Then there's primary data, which is new data you collect yourself, such as your own benchmark timings, and secondary data, which is data others have already gathered, like published benchmark results. Keeping those 4 apart makes the rest of this much clearer. There's a well-known way to picture all these decisions, the research onion from Saunders and colleagues. It imagines research as a series of layers you work through from the outside in. The outer layers set your philosophy and overall approach. The inner layers choose your strategy, the mix of methods and the time frame. And right at the center sits the actual data collection and analysis. The point is simply that your decisions move logically from the broad outer layers inward to the practical core. One of the biggest choices is between qualitative and quantitative. Quantitative work deals with numbers and measurement, answering how much or how fast, think benchmark timings, survey scores, or error rates, and you analyze it with statistics, charts, and averages. Qualitative work deals instead with words, views, and meaning, answering why or how people feel, like interviews about how usable a piece of software is, or the open comments on a survey, which you analyze by finding themes and patterns. Often, the richest projects mix both. Mixed methods might combine benchmark timings with users' comments on which drive actually feels faster to them. It's also worth remembering the difference between primary data, which you generate, and secondary data, which you reuse from reliable sources. Most student projects lean on primary data for the core result and secondary data for the background. So your own boot time measurements might sit alongside published benchmarks that put your numbers in context. In computing, you've got several data collection methods to choose from. An experiment changes one variable under controlled conditions, like swapping the drive and remeasuring. Benchmarking runs a standard test so you can compare performance fairly using something like a disk speed tool. A survey or questionnaire gathers many views quickly, perhaps on how aware students are of cybersecurity, and an interview or observation lets you explore usability in depth with just a few users. The golden rule is that your method must match your question, so a comparison of speed needs measurement, not opinions. Let's make that matching really concrete. Reach for an experiment when you can control variables and measure an effect, like a solid-state versus hard drive boot test on one laptop. Use benchmarking when you need a fair, repeatable performance comparison, say between 2 sorting algorithms' run times. Choose a survey when you want many responses on views or behavior, such as cybersecurity awareness among students. And pick an interview when you need depth on experience, for instance, comparing how usable people find Windows and Linux. You'll also need to think about sampling, which is who or what you actually test. A sample is the part of the whole population you study. Random sampling gives everyone an equal chance and reduces bias, whereas convenience sampling, like using your own class, is easier but less representative. Always state your sample size and how you chose it, whether that's 40 students or 5 repeated runs per test. And for experiments, repeat your measurements and report an average, because that smooths out random error. Finally, you have to justify your methodology, not just describe it. For the DRIVE project, the learner explains their approach is quantitative because the question is about measurable speed rather than opinion. The method is a controlled experiment on one laptop, so the only thing changing is the drive itself. The data is primary timings for boot, 3 app launches and a file copy, 5 repeats each, and then averaged. They justify it by pointing out that repeats and identical hardware make the test fair and reliable, while honestly acknowledging the limitation that results from one laptop may not generalize. Let's draw this outcome together. A project moves through clear stages: define, review, design, collect, analyze, and report. And a Gantt chart schedules those tasks and milestones while building in contingency time. The outline proposal sets out your title, background, aim, method, ethics, timeline, and references in one place. Your methodology can be quantitative, qualitative, or mixed, drawing on both primary and secondary data. And whatever you choose, you fit the method to the question and justify it, noting your sampling and any limitations. So that's the plan and the method sorted. If you want to strengthen this further, the further reading is a real help. Dawson on projects in computing and Oates on researching information systems both walk through methodology in depth, while Saunders and colleagues are the source of that research onion if you want the full picture. There's also practical guidance from the BCS on ethics and conduct, and the benchmark reports from bodies like TPC and SPEC are lovely examples of documented, repeatable experiments. Have a browse of a couple through the Moodle resources, and in the final outcome, we look at finding and justifying good sources.